Hello everyone. In this video, we're going to discuss about superconductor in Maglev Train. Maglev Train floats above ground by using magnetic repulsion for frictionless and high-speed travel above 350 miles per hour. Today's maglev technology relies on niobium titanium magnets housed on the train. Coated in copper for stability, these coils generate the massive power needed to hover and propel the vehicle. Inside the train's bogies, current maglev technology utilizes NBTI superconducting coils housed within specialized cryogenic tanks. As shown here, these magnets are located onboard the vehicle, interacting with the guideway to enable stable, frictionless levitation at record-breaking speeds. To keep these superconductors coil in their superconducting state with zero electrical resistance, we have to cool them using liquid helium at -269 degrees Celsius. To put that in perspective, that is nearly absolute zero. It is actually colder than the average temperature of deep space. Imagine the energy and the massive, high-tech cooling systems required to keep the superconductor cold to ensure the train can have stable floating above track while it's moving through a hot city at 600 kilometers per hour. That is the true cost of maglev, not just the train itself, but the battle against physics to keep it frozen. In engineering, we usually want a wide margin for error. But current maglevs live on a knife's edge. To stay superconducting, these coils operate at 4.2 Kelvin. Their breaking point? Just 9.2 Kelvin. That is a tiny, 5-degree safety margin. One small cooling hiccup, one tiny vibration, or a spike in friction, and you hit the cliff. Resistance returns instantly, the magnetic field collapses, and the system fails. Carrying all those heavy cooling tanks, with their intricate machinery and specialized insulation, adds significant dead weight to every single train car. This isn't just a small inconvenience, it's a massive drag on efficiency and performance. We're essentially hauling a mini refrigerator plant on board for every few passengers. But imagine a better way. The future of maglev lies in a few simple steps. First, we need lighter superconducting materials. Think less heavy metal, more advanced compounds that are powerful but don't weigh the train down. Next, a superconductor material with higher TC, so that the train can operate at higher temperature with larger safety margin. And lastly, we want a simpler cooling system. No more struggling with liquid helium. We want to use something much cheaper and easier to handle, like liquid nitrogen. To achieve all those needs, we can use a high-temperature superconductor, HTS. By switching to high-temperature superconductors like REBCO, we change the game. REBCO only needs to be cooled to 77 Kelvin using simple liquid nitrogen to reach its superconducting state. Its critical temperature, TC, is 92 Kelvin, nearly 10 times higher than NBTI. Because the material can withstand much higher temperatures before losing its superconductivity, the train no longer needs those heavy, extreme cooling systems. Now we get a massive safety buffer, a lighter train, and a system that can finally handle the heat of high-speed travel. To overcome the weight of traditional cooling, China's newest maglev prototype turns to a revolutionary material, second-generation REBCO HTS tape. This tape is incredibly thin, just 100 micrometers, or about the thickness of a human hair. But don't let its size fool you, it's a high-tech metal sandwich. The real breakthrough lies in the no insulation winding. By stacking these tapes directly, metal over metal, engineers have created a self-protecting magnet. In old systems, a tiny heat spike caused a total quench. Here, electricity simply jumps to the next layer to bypass the heat, keeping the magnet stable. This simple change reduces magnet weight by 50% and allows the train to run on liquid nitrogen, making 600 km/h travel lighter, safer, and more efficient than ever before. By ditching the heavy insulation and expensive cooling, we've finally unlocked the true potential of maglev. Lighter, safer, and remarkably efficient, the high-temperature superconductor technology, HTS, is the technology that will move the world. Thanks for watching.